So my name is Pavel Chunyayev. I'm continuous delivery architect at Levi9 IT Services. With my daily work, I help our customers to assess, create, and optimize the way they deliver their applications to production. And I'd like to talk today about feedback and about types of feedback that continuous delivery process can bring. And also, most important feedback, of course, comes through testing, and I will talk about testing and about types of testing, and again, what kind of feedback it produces. It will take about half an hour, maybe 40 minutes, depending on the pace. If you've got any questions or you want me to clarify on something, just raise a hand. It's very welcome during the presentation. If you disagree with something, or if you have something like yes, but, or what if, just let's do it after the talk. This is not something. It wasn't planned.
Durability of
MacBooks. Okay.
It was testing.
So, the feedback from this test is that, well, it looks okay. It looks okay after falling. So just to set a bit of a background, very shortly about the company I work for. The company is called Levi9. We are IT services software development company. We are a company of more than 700 people. Mostly located in 3 countries, in Serbia, Romania, and Ukraine, with a head office in Amsterdam. We recently opened office in Lviv and Belgrade. More people come there. We focused on the Dutch market mostly, and we develop software with these companies and for these companies, and a lot of these companies we develop core software for them. In 2015, in Hiarte survey, we reached 100% customer recommendation score. I believe this is cool. A bit about me. So I got 12 years working experience. I started in 2004. I come from Ukraine. I used to live in Estonia. Almost 2 years ago, well, in October it will be 2 years, but 2 years, I moved to the Netherlands to continue working. Some fun facts about me. I love cycling, and I needed to move here to find this out. I even bought a road bike for me and now for my wife as well. So I participated last year in Alpes. It's going up the mountain, and I was proud of myself. Then I participated in March in the Holland 100. It was 10 kilometers ice skating and 90 kilometers cycling. I failed 10 kilometers ice skating. I did only one round, 3 kilometers. And because, well, before December last year, I didn't know how to ice skate. So, it was first time on natural ice, and I failed miserably. I was doing one round, and while I was doing the first round, people were doing already the third one. And at the end of the first round, somebody hit me, so it was also not a pleasant experience. So I fell on ice. But then, after all, I did 90 kilometers cycling, and it was fine. I was also proud of myself, and afterwards, in June, I did Alpe d'Huez 2 times. First time faster than last year, and second time also improvement. So we'll see how it goes the next year. I love Dutch language, but love is in a way. Well, I love when I see it in perspective. Okay, I love that now I'm better at this than 2 months ago, but it's still kind of nervous experience. When I try to talk, but you can help me and spreek Nederlands met mij. And I know I asked some of you already, and some of you tried it. It wasn't always good, but again, I'm improving, so try me again. Okay, now a bit more serious stuff. So I am into software development processes. So my background is in IT operations. But I started with automation, with DevOps, with continuous delivery more than 4 years ago. But the more I work, the more I see that it's not only about technology, and it's not only about automation, it's actually a broader thing that you need to do to start improving things. And I call it software development processes, but maybe it's not the right word, but this is how I call it. And I like working with people. because also, You can't just code and think that it is enough. It's not enough. But if we combine those two, I would like to learn from you guys in the break. What are you doing? How you're doing this? Yeah, I would like to learn from you. Okay, this is, I guess, enough for the introduction. Now let's talk about feedback. And well, there is no better way to start than with a quote. So feedback is the information about actions returned to the source of its actions. This is what Wikipedia says. And well, it doesn't explain a lot, does it? But feedback is everywhere. It's in biology, it's in agriculture, it's in all the engineering, in any technology. And well, for us it's important that feedback is in software and in software development. If we generalize, this is what feedback is. It's just the output of the system that is connected to the input of the system, that allows system to react to, well, how the system operates. So it allows the system to be adaptive to some events that happen inside the system. And there might be two most important types of feedback, positive and negative feedback. With the positive feedback, we are really adding to, well, facilitating the desired behavior. We want more of this. We want to amplify things. With the negative feedback loop, we want to stop doing something. We want to to remove the undesired behavior, to get less of something. And this is, yeah, feedback is about this. Before we move to the feedback and how it applies to continuous delivery, I want to do an introduction of what I think continuous delivery and what I promote as view on continuous delivery. So this is what I think of continuous delivery. And well, it's not probably fair to call it continuous delivery. I think this is the view how we develop any software. It starts with the idea here. That is then, well, yeah, it's generated, it comes from the business. And the idea is turned to the epics, to the user stories, it's planned, it's prioritized, it's finally moving into sprint where the magic happens, then it's built, then it's tested, then it's released, and then it's finally in operation. And this is why we are doing this, just going through the whole circle, from here, from idea to operation. And the funny part of this is we want to do it as fast as possible. Times when we could spend a year on this or a month of this are kind of gone. And the problem if we take a lot of time is that the feature that was envisioned here by bright business people might be no longer needed. Or it is too late, or your competitors implement it faster and they steal all the market, and then you need to try a bit harder. So this is why people start talking about how we can do it quickly, but how we can decrease the time it takes between generating an idea and putting it into the hands of users. And this is why we're shortening and shortening and shortening this. But it's, I believe that the only good way of decreasing this time is through establishing the quality and through focusing on quality only. Unless you put all the effort into quality, you just can't do it faster because you will just release bugs faster. You don't want it. And if your users can't use your product, again, they will go to your competitors. This is not what you want. And or especially if you don't want these users to happen on Twitter or on Facebook. Oh, I tried new application, it sucks. We can't use it, and suddenly everyone is about this. Only with the focus of quality you can, if not remove these things, probably you can't remove all of those, but you can reduce them a lot. So this is why it's quality. And these are two main things that I think help establish the quality. It's keeping the product releasable and building the quality in. And by keeping the product releasable, I mean the idea where any change the developer implements is self-contained. Is you implement this feature or whatever you implemented, you commit a code and your application is still working. There is no such idea that, okay, you click a button and something is not happening because the backend is not working. You can't just do it like this. On every change, you need to keep the product releasable. and you need to build the quality into the process. Quality is not something that can be established afterwards, somewhere late in the release cycle. It needs to be taken from the first day, from the really as early as possible. So yeah, I believe if we're talking about keeping the product releasable and building the quality in, we're mostly talking about these three things, about these three stages, and this is what, with developers, you see this all the time. This is actually where all the work is happening, all the feedback is happening, because this is actually what consists the delivery pipeline. On one side of it, we throw the source code in. On the other side, we get the working software. And we go through this cycle of build, test, release for any change that we are producing. On the build stage, we just work with everything that makes sense to work with the source code. And as the result of this stage, we produce a version artifact. Then we move to the test stage. This is where all the testing happens. All the criteria that you came up with to ensure the quality of your software happens at that stage. No later there. And you can see there is no manual testing there. And then if the criteria are met, you move to the release stage. Whatever releases is for you. It can be downstream integrations, it can be deployment to production, it can be real release, whatever. And most importantly, the testing. So the thing that I believe is that you need to run all the tests at this stage. You need to run them in parallel. You need to prepare all the infrastructure when it's needed to run the tests, specifically for those kind of tests, because you might end up with a different infrastructure there, and then destroy it immediately afterwards. There is no DTAP, and I believe in more modern processes there is no place for DTAP street, because you need to make all the testing at one time. You can't just make tests later in the process. It's just too expensive. But then you need to run them together all the time. You need to run them over and over again so you can catch the problem if it happens. And this happens on every level. So if we think, if you have a complex build structure, you have this cycle for every component, but then if you need to integrate those components, you have the same cycle as well. And what build means can be different for one backend component, for another, for front-end component, for integrated environment. Build can be different, but most importantly, the tests are different on different levels. Ideally, you need to move all the tests to the left. This is, in this process, is put the tests here. But most importantly, that you need to run different types of tests. You need to always think, do I need to run tests on an integrated environment, or I can ensure the quality on the component level? Because the earlier you test, the earlier you find the bug, the easier it is to fix it. Getting back to the feedback. So, I believe feedback is core of any agile or lean process. Oh, it's never said in a book like that. But I believe the whole idea of lean and agile is to be always aware of what's happening with your product, how it is being developed. Are we still on track? When we will release this feature? Are developers happy or not? Do we need to change anything in the process? We can answer all these questions only when we get feedback from the process, feedback from the systems. In most cases, feedback comes in a way of, well, metrics. We can produce 15 story points in the sprints. But it doesn't have to be. It's just this is how, in most cases, we experience feedback, by numbers, by KPIs, by, well, by measurements. But then, if we move to the continuous delivery and think what kind of feedback is possible for continuous delivery, I would like to split this whole story of feedback for continuous delivery into two main groups of users who need to receive feedback. And those are development teams and business teams. And let's start with development teams. What kind of feedback do they need, and from which stages do they need? Well, it is from all of these, I believe. From every stage. So from build stage, We can receive feedback, well, how is my application being built? Is it fine or not? How are my unit tests? Is the code okay? The code quality, is it okay or not? All of these questions. In the test is the feedback if it is the quality software. And if it's not, what do I need to do? Where the problem is? Fix. This is the kind of feedback. From the release, it can be deployment, or it can be integrations. Is it working correctly or not? Are we still closer to our mission or not? And finally, operation. And this is why I believe DevOps movement appeared, to bring this feedback to developers. Because developers need to know how their software operates in production. From performance perspective, yes. From bugs perspective. And if you think of this, this is an interesting feedback loop. There is like the famous thing that you build it, you run it. As soon as developers start receiving at night pages that the application is broken, they are pushed towards creating quality software. Because the feedback that they receive is a negative one. It doesn't allow them to sleep well at night. Same with the performance. If it's not working correctly, the developer needs to see it. Otherwise, in some companies or in old-style companies, this can be a different department. Okay, there might be a different test department, and then there is no feedback. Some other people are doing testing. How are they doing this? Who knows? And then all the problem starts. It works on my computer. It doesn't work. It's not a bug. It's a feature, and all of those things. Because it just it's not a feedback when another person comes to you and tells you you did a bad job. This is kind of feedback, and we humans are bad in providing these feedback, because, well, it's easy to say you did a bad job, but probably, oh, no, I was fine, it's you found out the correct thing. But it's hard to do the same with the metrics, measurements, or the processes that provide feedback to you, because they don't care about you. They just give you pure information. Then if we move to the business, I believe starts here. They need feedback from all of these stages as well. They need feedback from planning. Okay, how do we split this bright idea into epics? How do we prioritize this compared to our other features? When will it be delivered? With the coding, how is sprint of the team going? Will they probably release this new feature this sprint or not? This is the kind of feedback you want to receive. With the build, well, maybe this is the stage, not very interesting. But from my experience, business people like to see green builds, and they don't like to see red builds, the broken builds. And this is the feedback that can be provided to them as well. Tests. And this is important part of feedback, because this is what gives the business the idea of, are we still providing the features that we promised to users? And if we're creating new features, is it what we requested or not? Test is very important for business. Release, yes, how it goes. An operation is, are we making money or are we losing money? Are users happy with our software or not? Additionally, we need these two types of feedback to developers. And I believe this is forgotten in a lot of companies. The question is, what are we doing here? Like, for whom? Why? The roadmap. In a lot of companies I see this is just, developers have no clue. They see this endless loop of sprints. Okay, next sprint, next sprint, next sprint. But they don't see the big picture. And this is the kind of feedback I believe developers need to receive. Now, quickly, if we can think of this pipeline as a bit of a different way, how it goes into lean startup. But the story is still the same, and the feedback is still the same. We iterate through build, measure, learn cycle. We come up with the idea, we implement the idea, we see if idea is needed by users, and if we need to invest more into this, or maybe it's not needed. And just the same representation, just in a different view. But the thing is the same. Without feedback, you just can't get this information. Now, let me get you acquainted with the testing pyramid. or you know probably it already, but still, I will tell the story of feedback in the testing pyramid. So the idea is that the testing pyramid shows the amount of tests that needs to be created for every product. Okay, most need to focus on unit tests, then integration, contract, and then testing, and all the rest of the testing on top. And there are several perspectives on the pyramid. Most important perspective is amount of tests, but then execution time. The closer we're to the bottom of the pyramid, here milliseconds we're talking. Even when we get to end-to-end test or manual testing, here maybe we're talking about hours. Here maybe weeks, depending on the product. And the same idea. The feedback loop needs to come as soon as possible. And if we rely on manual testing, and if we don't implement the testing pyramid in the way we create the ice cream cone, then the feedback will come a lot later when it's too late in the process. But then another perspective of this is the higher we move to the top of the pyramid, the bigger feedback to business we get. And the opposite, the more we move to the bottom of the pyramid, the more feedback to developers we get. If the unit test has failed, it means nothing to business. It means, well, the product is not working. But this is the kind of feedback developers want to receive, because then you know exactly what is broken and you know where to fix it. When end-to-end test fails, okay, the business knows that this specific feature is not working. Where to fix it? Good luck finding out. So you can spend hours and then find out. This is why we need unit tests, we need integration tests, because they allow developers to quickly fix the issues. But we also need end-to-end tests as well, because those speak with the language of business. These are the features and they're still working. Quickly, the type of feedback that we can get from the different types of testing. Unit testing is mostly feedback to development. Your objects, your methods in the objects are still working, and they're working correctly as you design them to work. If you don't have any unit testing, aiming for 100% coverage probably is a good thing, but I don't think that it is a valid method. It's more, how do you find regressions? There are tests for unit tests, but this is a very different story. Then we go to integration testing. It's also kind of most important feedback to developers. This is how different objects communicate, how they work together, or how they cooperate with the third-party services. This is a very important type of feedback for development teams. Then, and I'm talking more about microservices, of course, architecture, of course. Anyway, we move on the level of microservices, and this is the contract test is what starts to provide more and more feedback to business, but they also provide important feedback to developers as well, because this is this black box testing. You might think of this. If we forget about what's inside, is our service providing what we promised it is providing or not? And this is what is called contract testing. It's important feedback to both business and to both development. And if we go to end-to-end testing, this is again a level of integration of the different microservices, or a level of the whole monolithic application, how it performs as a whole. Here we can talk about user journeys or how people use system, but this is the most important feedback to business. We're still building the right product. Now, if we abstract a bit, I think of these 4 types of testing as, they have in common the idea that if we think about unit and integration testing, they happen inside one microservice. But then if we abstract from what's happening inside microservices, contract testing is kind of a unit tests for microservice. You do the same thing. You send inputs and see how the service reacts to it. And end-to-end test is kind of integration test, because you're testing how different microservices communicate to each other. Okay, they're completely different how you do those, but logically I think of them as more or less the same, just which level you're testing against. A bit more about some types of testing. So I believe the contract testing is the most important type of testing that appeared for microservices. But it's also important even to more monolithic applications. It's just I've never saw implemented it for monolithic applications. But it's important because, okay, it's, be it microservice or be it component, it creates some kind of promise. What kind of service I can provide to you guys, to other microservices or to, well, some external consumers. And this is what we need to test because we don't want to break the contract. There are two types of approaches to test this contract. One is called consumer-driven contract testing, another one is called producer-driven contract testing. Producer-driven contract testing says that, okay, I know what I promised to you, I will test that my promise is still valid. I will only create the test. Consumer-driven contract testing says, okay, your users can tell me how you're using my service, and I will use this information to test my service. So I don't break the contract for how you are using it. The difference is subtle, but it is in a way that how exactly you're doing this. Who creates those tests? Your users or your consumers or you as the team who produces it? And ideally, you don't want to change your contract ever. In a ideal world, you have only one try to make it right. Because every time you change the contract, this is an expensive game. This is an expensive procedure. Because people started using it the way you promised it. And people need to invest time, effort, and money to change the way you're doing this. And okay, if it's internal contract, it might be easy. You can go to the guy, have a video with him, explain, and he will change it. But if this is a promise to external customers, in a lot of situations you have no control into that. And they might say, whoa, we have a signed contract with you, you can't just change it. So in ideal world, you need to create it once and for all. Unfortunately, we're not in an ideal world, and in most cases you need to change this. For that you need to version. Okay, how to version is a separate story, be it 1, 2, 3, semantic version in major minor, be it in URI or in metadata. There are a lot of discussion over this on the internet. I want to get just one idea that you can't just change the contract. You need a way to, if you want to transition, you need to have to arrange it in a way that for a long period of time you will run both versions of contracts. It happens like this. So imagine we have a service with the contract 1.0 and some services consuming. You want to transition it. You transition to 1.1, but you're running those two together and you're testing those two together. Then you announce to people, well, here is new version. And people start transitioning. And between these two things, it can be, well, days, months, years, depending on how lucky you are. But only when every consumer has moved to the new version, only then you can deprecate the old version. And this is not a fast process at all. This is why you better not change the contract, because this is expensive and this is hard. But again, this is the reality. Don't break the contract. This is the main thing. Test over it. This is what you users do. Performance testing. Quickly, I want to talk about 3 things and 3 types of feedback that I believe are important for performance testing. First of all is how fast does my page load? And you need to have some ambition there, but set it appropriate. Be it the page load or API response, but you need to measure it and you need to have this feedback loop to be able to know how's happening and if it's degrading, react on it. But second thing is how many users you can have and they can consume your service simultaneously. And again, this is an interesting type of feedback because it allows you to size things but also improve things. And finally, how soon you can scale and how easy you can scale, because this is also another type of feedback for performance. If your application has sudden burst, how soon you will be able to react on it? Or will you just degrade or stop working? Performance testing provides this feedback in a confidence type for business that, okay, we're safe to go, we're safe to operate our application in production. Manual testing. Well, I don't like manual testing, really. I think there is no place for manual testing in the process. However, I believe there is a place for exploratory testing. This is something that I believe is needed because it allows people to, well, get familiarized with the system, look at the system through the eyes of users, and even try things, some things. Before you even go to automating tests, you might want to see what to automate, how you can ensure that the system is working. So it starts always with this exploratory or manual testing. And some of the ideas you won't be able, some of the exploratory tests you won't be able to automate ever, so you might still need to run those. But to me, most important part of exploratory testing is that it gets this tool for developers and for testers to try the system, to learn how it's working, and then to get their own feeling of the system. Finally, resilience testing. And well, it's also very important to data feedback, because if you look at this system, what will happen if this service dies, or this service dies, or these two die, or the grandpas die? Will it be still working or not? And this is, again, very important type of feedback for business, how ready we are to operate under real-life circumstances, but also for developers. Are we creating the resilient system or not? And how we can, if we start losing this service, how we can make the system work. A couple more ideas to start finalizing. Who creates tests? Interesting question that, yeah, scares everyone. I think developers need to create tests. I think there is no better person but a software developer to create tests. However, there is a problem with this statement, because developers are known to be bad at creating tests. Developers are known to be bad at creating secure software. And there is no workaround around this but to teach people, but to teach them how to do it correctly. To teach them through exploratory testing, for example, how to look at the system through the eyes of the user, how to break stuff, how to think even to this, yeah, how would you ensure that the code you are creating is the one that should be working? Because again, ideally you should create a test whenever you create a feature. In the same time or before, yeah, if you prefer TTD, but not afterwards by somebody else. And especially if you change some feature, you need to change the test. Otherwise, you will go to your delivery pipeline, and your test will fail, and it will be okay. We just haven't updated the test. It's the wrong feedback that you're providing. It's the wrong behavior that you are facilitating. Because you want, with any change to software, you want to keep it releasable, and you want to retest it. And you want it to, so ideally, with the same pull request, with the same commit that you're doing to change the code, you need to change the tests. And the test should belong to the same repository. Instability and slowness. This is what happens when companies start automating tests just from looking at the test cases. Oh, we have 300 test cases, let's automate them. And suddenly, half a year later, some of the tests are sometimes green, sometimes red. This is called flaky tests. They need to be removed completely. They don't provide good feedback. They provide wrong feedback. they provide the feedback. Oh, the test has failed. It's okay. It's always failing. Try the second time. And what is wrong with it? It shouldn't be like that. Because the right type of feedback, the test has failed. We need to stop doing whatever we are doing and immediately fix those. Not rerun them. Not maybe it will work, because then you will end up 3 times rerunning. No, it's still red. Probably it's finally broken. No, it shouldn't be like this. And the same with slowness. If your tests take hours and hours to complete, the feedback will come just too late. And this, if you remember the slide with the parallel testing, you need to parallelize your tests. You need to randomize your test suite, so you won't create specific order, specific dependencies between tests. But most important, I believe, you need to create an idea of time to live for testing. You need to finish your testing within 2 hours. And this will force the teams to parallelize it And yeah, because if a testing takes 10 hours, split them into 5 streams, it will run to 2 hours in total. But this is very important because the feedback in 10 hours, it's too late, I believe. It should be, even 2 hours is too late. Even 1 hour is okay. Ideally, feedback should come as soon as possible after you commit, after you code, you test it, it should be quicker. Maybe my ideal time would be to go for coffee, return back, and here's your feedback. Everything is fine. You can continue. But this is, yeah, of course, not always possible. Finally, the feedback from release and deployment and the difference between them. So they are different, you probably know this. So deployment is an act of putting the code or the binary to the server, while release is making this code work and make it available for users. And this needs to be separated because in some processes implemented, you always deploy, but you don't always enable the feature for users. Be it reflection tolling or any other technique. And deployment provides nice feedback to developers, okay? We can still continue working to developers, I said, yes. And it also provides feedback to business. We are aggregating features. We soon will be able to do a marketing release. We are on track, everything is fine. And when the release comes, developers probably, well, they don't care if they don't have feedback loop from the operation. But if they do, release comes, the features are totally set, developers can see how their code is finally working in production. You can emulate this on some test environment, but it's only production when you start looking at this. And for business, the feedback is, yeah, finally it's working. Here are new features that will generate us a lot of money. So yeah, this was about feedback, about adaptive systems and what types of feedback we have for continuous delivery. And just to have the main 4 ideas that I wanted to communicate, and I hope you will remember from this presentation, is keep the product releasable. With every commit you do, you need to keep this in mind. Build the quality to the system, start testing as soon as possible, and automate this to provide right feedback. Do it through frequent and incremental releases, just to be able to safely release. And yeah, run continuous improvement, because only with feedback you can improve all the time through, be it positive or be it negative feedback. And this is it. Thank you. And it was 38 minutes, 30 to 40, as I promised. Any questions?
Yeah, of course. You were mentioning in one of your previous slides the test cycles, where you define provisioning, infrastructure, and disposing infrastructure. What is your best practice in that? Because I saw that I think it was the parallel testing slide. Yep. Yeah. So how do you keep your environment consistent? So what are your best practices? Probably it's not part of this presentation.
Yeah, but still, so your question is how can we create this environment, or what do you mean by keeping consistent? Yeah. Well, you can, if you run infrastructure as code or Docker containers or whatever, you have means to recreate your infrastructure at any time. And this is the big benefit, because you know exactly how much time it will take you to provision infrastructure. Again, be it 1 hour, be it 15 seconds, you need to know this time, and it needs to be repeatable and reproducible. And then when you automated this, you can automate this process. Okay, we're running these 5 types of tests, just theoretically, in parallel. Let's create 5 environments for those. Let's run those tests and then destroy these environments. Because that environment per se loses its value because you can create it any time. And this is why I'm promoting just stopping using DTAP, because the idea of DTAP is that you get hold of that environment or that server and you keep it forever because you can't get another one. But in a world where you practice immutable infrastructure, it's a lot easier. You can run the same infrastructure locally or remotely. It will be identical. But you need to first of all do those steps to run this configuration management, to create this automation to provision infrastructure. Well, you can always ask quick questions later, of course, but here's the agenda.
On your slides you mentioned the testing pyramid with types of testing, but later you also were talking about the performance and resilience tests.
All of them belong to the top of pyramid.
Blank triangle.
Yeah. The top triangle. They are very, very important. But the thing is that you need first to focus on the rest of the things before you can even go to performance. It makes no sense to even continue with performance and resilience if you're not safe to change the code. Because you need unit integration tests, contract tests to be safe to refactor or change the code. Otherwise, any change is potentially breaking the system, and you won't even know it. This is the worst scenario, because if you don't have those tests, you can learn it months later, if not years. Suddenly, then, yeah, it's too late.
When you were talking about feedback, you said that the build should also get feedback to the business.
Yeah.
Because they like green lights. Well, they don't like red lights, but don't you think that this kind of fight with the principle to supplement the developer with continuous feedback, that this build breaks, it prevents him from committing the code because he knows that he will get punished from management, let's say?
So your question is, should business get this feedback as well, or is it feedback for developer only?
Feedback, yeah.
I still believe that business needs to take to receive this feedback. The question is how they react on it. If the reaction is you broke the build, we need to punish you, this is wrong reaction. This is not what you want to facilitate. You want to facilitate a bit of a different thing. Yeah, it happens, but we can learn from this, because broken build is essentially, well, something went wrong. If you just learn from this, add it to more testing, or arrange it in a way that you don't see the same problem again, then red build is a perfect thing, because you will never have the red build for the same reason. And this is what I believe type of feedback that needs to go to business. It happens, but we are improving all the time based on this. Again, no punishment, because failures happen. It's how you react on those. This is what makes it different. You either punish or learn. You better learn than punish. Yes, please.
I have a different question from a different angle. So one of the testing there was E2E testing. How do you actually read no feedback whatsoever, and how do you change the culture of your end user?
So the question is, how do you change the culture of user through end-to-end testing? Or?
Correct, yes. So let's say if you're conducting some E2E testing and you're getting no feedback from the end user. So how do you get more engaged with your users?
So when I'm talking about end-to-end testing, they actually don't come from user. They are synthetic tests.
Okay.
Users are testing everything in production. This is where operation. I didn't talk about this at all in the presentation. But then, yeah, I'm not sure what to ask them. If it's end-to-end tests, you need to think how you create those and what do your end-to-end test cover. And this is a big story on itself, how you create this user journey or personas, because you don't need to test every test case or to cover every test case with end-to-end. If this answers your question, not really. Okay, it does. Good. Then, thank you.